Math 3 Lesson Summary Video. Guess my parallelogram. This lesson is a practice understanding task, which takes concepts you have been working on and applies them to new situations. The purpose of this lesson is to become fluent in identifying special types of parallelograms based on descriptive features of the parallelogram. In the task, Tahani and Tia are playing a guessing game and are trying to figure out which parallelogram the other is describing. In class, you should be going through all of their claims and trying to find ways to prove properties of the different quadrilateral parallelograms. At the end of class, after everyone in your class has had a chance to try and prove their claims, conjectures, and arguments, hopefully, you will capture a lot of information about the different quadrilateral parallelograms and what their specific properties are. If you missed something or were absent, here are some of the things that you should have captured. In the previous lesson, we had already established what the properties of a parallelogram were. It is a quadrilateral whose opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, diagonals bisect each other, and the consecutive angles are supplementary. So we knew these properties about a parallelogram. Here you see there are three other specific types of parallelograms that have more specific descriptions. The rhombus has all of the properties of a parallelogram because it is a parallelogram. But it also has all four sides are congruent. That's what makes it a rhombus. All four sides have the same length. Because of this, it actually makes the diagonals turn out to be perpendicular to one another, and the diagonals bisect their angles. In class, you wouldn't have just been given this information, but we would have tried to figure it out by looking at and playing with the shapes. For example, if we have a rhombus, then we know that all four of the sides are congruent to each other. But because it is a parallelogram, we also know that the diagonals bisect each other. So these two segments are congruent, and these two segments are congruent. And because of that information, knowing it's a parallelogram and knowing that all four sides are congruent, notice that we have three sides of a triangle for all four of these triangles. We have side, side, side. All four of these triangles are congruent. And if all four of these triangles, are congruent, then we have a lot of corresponding parts of congruent triangles that we now know are congruent. For example, this angle is congruent to this angle, is congruent to this angle, is congruent to that angle. That's how we know the diagonals bisect each other, because we also know that these four angles are congruent. And so we know that the diagonals bisect each other. Because these two triangles are congruent, we know that this angle and this angle are congruent, but they're also a linear pair. They make a straight line. So if they're congruent and they add up to equal 180 degrees, then they must be 90 degrees, which is how we know that these angles are right angles and that the diagonals are perpendicular. So when you were going through and you were looking at all of Tahani and Tia's comments and their claims, these are the types of things that you were looking for. You were trying to find how would we know that that is true. And we're going to use everything that we've learned so far, properties, postulates, theorems from Math 1, 2, and so far in 3, to help us to get to that point. So you didn't want to just know these properties. You wanted to know why they worked out to be the way that they did. Now, for a rectangle, it is still a parallelogram. So it has all of the properties of a parallelogram. It also has all four angles are congruent. So notice, rectangle and rhombus are kind of on the same level in the parallelogram family tree. Here, all four sides are congruent, but in a rectangle, all four angles are congruent. Now, if all four angles are congruent, we know consecutive angles are supplementary. That's one of the properties of a parallelogram. So that means that they have to be 90 degrees. So all 4 angles turn out to be 90 degrees. We also find out that the diagonals have to be congruent. And again, we didn't just take that as a rule. It comes from our congruent triangles. When we look at these diagonals, we've already established that we know the angles are congruent and that they are 90 degrees. We had already figured that out. We know that this side is a shared side between these 2 triangles, the reflexive property, so it has to be congruent. And we also know that these 2 sides have to be congruent because it is a parallelogram, so opposite sides are congruent. Now we have side angle side to prove that this triangle is congruent to that triangle, which means that this diagonal is congruent to that diagonal. And so now we have our properties of a rectangle. If we're looking at a square by definition is a parallelogram where all 4 sides are congruent and all 4 angles are congruent. So notice on our family tree, it is a rhombus and it is a rectangle, which means it has all the properties of a parallelogram, but it also has all of the properties of a rectangle and all of the properties of a rhombus. So when we look at a square, we have all kinds of equal things. We have 4 equal sides. We have 4 90-degree angles. But we also know that its diagonals are congruent and its diagonals are perpendicular because it is a rhombus and it is a rectangle. So it gets both. And we also know that it bisects these angles, so each of these little angles have to be 45 degrees. And we know that the diagonals still bisect each other, so we end up with all these little equal segments on the inside. And so you just end up with all of these equal pieces in a square. Now, you may or may not have had some time in class to also investigate a couple of the other quadrilateral shapes. In case you are not familiar, a kite has 4 sides, but none of them are parallel. All right, our properties of a kite are that it has 2 adjacent pairs of sides that are congruent. So 2 sides that are directly next to one another are congruent, but they're not parallel, and opposite sides are not congruent. So that's something that sets it apart from the parallelogram family. Now, things that we know about a kite: opposite angles between the non-congruent sides are congruent. So that means this angle is congruent to this angle. Okay, the ones that are between the 2 non-congruent sides are congruent, but this one up here and this one down here are not. This one is obviously obtuse and this one is quite acute. They are not congruent to one another. So that is one of its properties. We also know that the diagonals bisect the non-congruent angles. So these 2 angles here that were not congruent to each other, we know that they have to bisect those angles. We also know that the diagonals are perpendicular. So when you draw your diagonals, we do know that those diagonals are perpendicular. Now, that is a trait that the rhombus has as well, but it's because the rhombus is a kite. Notice how rhombus is attached to kite and parallelogram. A rhombus is a parallelogram because opposite sides end up being congruent. But it's also a kite because I do have consecutive pairs that are congruent. It's just that all 4 happen to be congruent. So a rhombus really has all of the properties of a kite and all of the properties of a parallelogram. So it is related. We also have properties of trapezoids. Again, what sets a trapezoid apart from a parallelogram is that only one pair of sides is parallel. So you don't get the 2 parallel sides. So we don't really end up with nearly as many things being congruent, if any. Occasionally, you do have a special type of trapezoid called an isosceles trapezoid. And what sets it apart from the rest of the trapezoids is that its non-parallel sides are congruent. It is basically like we took an isosceles triangle and chopped the top of it off parallel to the base. So we do have one pair of parallel sides, and we have one pair of opposite sides that are congruent. Because of this, we do end up with base angles being congruent. So the two base angles along this base of the trapezoid and the two angles along the upper base of the trapezoid end up being congruent.